Welcome to Get Your FRQ On. This question is from 2009. It's question 2, and it is calculator active. In this question, we have people attending a concert at an auditorium, and we're given a rate function, R of t, that tells us the rate at which people are entering this auditorium for the 2 hours before the concert begins. In part A of the question, we're simply asked how many people are in the auditorium when the concert begins. Well, if R of t represents the rate at which people are entering, the total number of people entering would just be the integral of that rate function over the 2 hours before the concert begins. So we're going to integrate R of t from 0 to 2. This is a calculator active question, so use your calculator to do this unless you like doing it by hand. But you can do this with a calculator, and it turns out that there are 980 people in the auditorium when this concert begins. In part B, we are asked when is the rate of people entering maximum and to provide justification. The rate function we have for the rate at which people are entering the auditorium is a polynomial function. And because it's a polynomial function, we know it's continuous on the closed interval from 0 to 2 and differentiable on the open interval from 0 to 2. And then the rate at which people entering this auditorium is going to be maximum either at an endpoint of our interval, so that would be 0 or 2, or somewhere between 0 and 2 such that r prime of t equals 0. Now, sometimes you could get a maximum somewhere in an interval where the derivative is undefined, but since this is a polynomial, it's differentiable everywhere. There's not going to be any of those points. So we don't really have to consider that as a possibility. But r prime of t being 0, that can definitely happen. All right, so we find a derivative for r of t. R prime of t is 2,760t minus 2,025t squared. Setting that equal to 0, we can solve that. It's either going to equal 0 when t is equal to 0, or when using our calculator, figuring out that t equals 1.36296. You might want to be a little bit careful with how quickly you round a value like that. Actually finding the maximum is probably going to require that we evaluate this function at that specific value of t. You don't want to round it now because your calculator might round it more when you plug it into the function. So in an intermediate step, you might want to consider keeping that decimal value to more than just 3 places. But those are the two possibilities when r prime of t is equal to 0. We do still have to check the endpoints, though. So plugging in 0 into our rate function, we get 0. Plugging 1.36296 into our rate function, we get 854.297. One thing to understand here is that is in people per hour, not people per minute. 854 plus people per minute would be ridiculous. And then r of 2, that just turns out to be 120. So looking at these 3 values, the endpoints turn out to be 0 and 120, and then the rate at t equals 1.36296 is 854 and change. So from this, it's pretty obvious that the rate of people entering is maximum at t equals 1.363. In part C, we're given that there exists a wait time function w of t. We're not told what w of t is, but we are told that the derivative of w of t, w prime of t, is 2 minus t times r of t. And then we are asked to find w of 2 minus w of 1. All right, so w of 2 minus w of 1 looks suspiciously like the fundamental theorem of calculus. And since we know w prime of t, if we think of this like a fundamental theorem of calculus problem, w of 2 minus w of 1 would just equal the integral from 1 to 2 of w prime of t, which would equal the integral from 1 to 2 of 2 minus t times r of t. Okay, This is a calculator active question. We can certainly calculate this on our calculator, and it turns out to be 387.5. So W of 2 minus W of 1 is 387.5. All right, the total wait time for people arriving to the concert between t equals 1 and t equals 2 is 387.5 hours. That just depends on how precise you want to be in your answer. Do you just want to leave it with the calculus? Do you want to verbalize what your answer is? That is up to you. In part D of this question, we are asked to find the average wait time, and this would be per person, which adds a little wrinkle to this question, which even threw me for a loop the first time I saw it. So the average wait time is going to be an application of the average value of a function, which is an integral problem. Okay, fine. We would have to integrate from 0 to 2 of 2 minus t r of t dt. And then our interval here, this is not in terms of hours. This is average wait time per person, so our interval here is not the interval from 0 to 2. It's an interval whose length is the number of people who are in this auditorium when the concert begins. So think back about what we did, I believe, in part A of this question. We actually had to figure out how many people were in the auditorium when the concert began. It turned out to be 980. So the length of our interval here is 980, and so the value of this integral from 0 to 2 of 2 minus t r of t dt, we actually have to multiply that by 1 over 980. That turns out to be 760 over 980, which is roughly 0.776 hours.